All right, everyone, here's another one. Bust out a paper and pencil. We're gonna get started. Today we are going to cover dilutions and concentration of ions because, in short, I feel like they go together, but in our textbook, they are chapters apart. Okay, so I am going to assign questions from pages that clearly are further away from each other, but again, I think that the train of thought is sort of overlapping in both topics, so bear with me, do your best. The first video that I'm doing is going to cover dilutions. The second video following that after your practice is going to cover concentration of ions. By practice, what do I mean? I'm talking about this section. The top set of questions is referring to chapter 8.7, that is dilutions. And then the bottom one is from page 447, is going to cover concentration of ions in chapter 9.5. All right, please bear with me. I'm going to do this in one take, but I feel like I have a lot to say about this section. It's not complex, but all these analogies and whatnot. If I'm jumping all over the place, please give me a break, forgive me, and give yourself the opportunity to maybe see this video once again. Dilutions. What is a dilution? In short, you're adding water to make it more dilute. That's the easy definition of it. It doesn't necessarily have to be water. You're basically adding a solvent to lower a concentration. Here's an example. Let's pretend I have, a beaker of some solution. Okay, let's pretend this is like 1 liter. And inside it I have, I don't know, 4 moles of something. Okay, so volume equals 1, number of moles equals 4 liters and mole. What's the concentration? N divided by V, it is 4 moles per liter. But then let's pretend I add the solvent, typically water, to this so that the volume is now 2 liters. I added water to this, remember? I didn't add any solute to it. So how many moles of the solute is still in this solution? Well, the answer is 4 moles. So if I were to work this out, the volume is 2 liters. The number of moles have not changed. So the concentration, quick maths, 2 moles per liter. The concentration was halved because we increased the volume. That's basically dilution. There's an actual formula for this, and I'm going to try to, again, bear with me. Let's put it this way. From solution number 1 and solution number 2, let's call this to be the number of moles is 1 and number of moles here is N2. Is the number of moles on the first solution and the second solution different? The answer is no. The number of moles, as we said, is the same. Right? That was really not clear. Okay, they're the same. So that means there is something else going on. The volume and the concentration, as you know, is connected by number of moles. Remember, if C is equal to N over V, multiply both sides by V. What is N equal to? C times V. So instead of writing N1, I could actually rewrite this as the concentration of the first solution multiplied by the volume of the first solution is the same as the concentration of the second solution multiplied by the volume of the second solution. I said, I can say this because I know that the number of moles is equal to CV. So if N1 and N2 are equal, then CV of the first one should also equal CV of the second. And there's your equation. For dilutions, because I haven't changed the number of moles, C1V1 must always equal to C2V2. You get me? Let's try it. Let's take these numbers and plug it in, if that makes sense. C of the first concentration is 4. V of the first concentration is, first solution is 1, and that equals to 4. Concentration of the second solution is 2. Concentration of the volume is 2, and that equals to 4. It always has to check out. And that's pretty much it. I'm going to try to show you this formula in action. So anytime you talk about dilutions, you can essentially, I don't know, put this to use. My first sample problem, let's see. I have a little book that I found, a nice one. Again, if you don't want to wait for me, I will make a timestamp on the bottom for you so that you don't have to wait. Here is my question. You have given a 18.0 moles per liter concentrated stock solution of sulfuric acid. And by the way, stock solution basically means solution that you will find stored, or a solution that you can get from a industrial company, or a solution that is very, very, very concentrated, and we have kept it inside a lab for whatever use, and we take that and we create whatever concentration we want. Anyways, enough of that. Given a 18 moles per liter concentrated stock solution, oh my gosh, a 18.0 moles per liter concentrated stock solution of sulfuric acid. Let's see, what volume would you need to prepare a 1.5 liter of 0.50 moles per liter sulfuric acid solution? Okay. So at first glance, it might seem a little daunting, I suppose. But again, if you look carefully, I have given you all the numbers you need to use that formula that was provided. Okay. Given an 18 moles per liter concentration, oh, I spelled that wrong. Anyways, right? And then there's this, there's that. Let's take a look. Reading this question, you know that I am starting with a concentration of 18 moles per liter. They're asking for the volume I would need if my resulting concentration is going to be 0.50 moles per liter, and I need 1.5 liters of that for, let's say, Mr. Kim wants to prepare a stock solution, quote unquote, for my grade 11s for a lab, right? And they're going to use this 0.50 molar concentration because it's safer. And if they accidentally touch it on their hands, it's not going to rip through their fingers and, you know, melt their hands up to the bone. And, you know, all they have to do is wash it off with water, right? Oof, that was a little morbid. Anyways, let's apply this formula. C1V1 is equal to C2V2. 18.0 multiplied by V is equal to 0.50 multiplied by 1.5. 18 times V is going to equal to, where's my calculator? Oh, it's 0.5, I'm so stupid. 0.75. That means the volume, V1 of course, is going to be 0.75 divided by 18, and that is 0.04166666. Repeating, sig figs, Therefore, 2 sig figs, I need 0.042 liters of stock solution to prepare for my students. And that's it. The magic of this is normally this would technically be a stoichiometric calculation. We have to take the concentration, write out some kind of chemical equation, and then turn it into moles, transfer over, and come all the way back. But the formula itself, it's sort of already done for you, so we can apply that when you're talking about dilutions. How about we do a slightly more difficult question, maybe? Right? How about I think it's virtually the same question, but I'm going to add a twist to it. Okay. How about we do it one more time? And this time I give you a chance. Pause the video before you, I guess, keep watching, and then give it a shot before checking your answers. A stock solution of 4.5 moles per liter of zinc sulfate is used to create 325 milliliters of 0.1 molar zinc SO4 solution. Okay, part A, how much of the stock solution was used? And part B, how much water was this added to? Notice how I say, by the way, I wish I was here to sort of demonstrate and stuff, because dilutions is where you get to learn lots of practical lab techniques, like using a pipette. If you're not sure what a pipette is, but you've seen like scientific shows, it's sort of, there's like a little tube thing with the handle, with a little rolly thing or whatnot, and from it comes a glass tube and a tiny snout at the end with all these volumetric measurements to make sure you are using the exact correct amount, right? Anyways, you get to learn that stuff, but unfortunately, due to the circumstances, we cannot, okay? But don't feel too bad. Anyways, the stock solution is that. How much of the stock solution was used? How much water was added to this? The reason why I wrote it this way is because that's exactly it. You do not have a super concentrated solution and then add H2O. That is asking for trouble. What you're going to do is take this much, have the amount of water you need for dilution, and put the small amount of the concentrated solution inside a body of water. That is the proper way to dilute. If you did it the previous way, let's just say that there are instances where vigorous amounts of heat can come out to the point where you might hurt yourself. And I'm constantly just erasing the text. What the heck is going on? Oh, geez. Anyways, let's get back to the question. Stock solution, so I'm starting with 4.5 molar. I am creating 0.1 molar. I am creating 0.325 liters of it. Please make sure it's in liters, because molar is moles per liter. Okay. How much of the stock solution do I need? So just like before, CV equals CV. 4.5 times volume is equal to 0.1 times 0.325. So V is equal to 0.1, 0.325 divided by 4.5. (0.00722) is approximately 0.007 liters. 7 milliliters of this if I want 325 milliliters of that. That's part A. Part B. If my total volume is 0.325 liters and 0.007 of it is the stock solution, well, then that means I must have added 0.007 into 0.316 liters of water. Okay. It's a practical lab application. That means I filled a beaker with 318 milliliters of water, and then using a pipette, I collected exactly 7 milliliters and put it in. This is dilutions. Welcome to solutions, okay? We're getting a little bit more mathy. Hope you're keeping up until now. Would you try studying the sample problem in page 404? Try numbers 1 to 4 because the answers are right next to the question. And then the chapter review or the section review, numbers 1 to 8, the answer should be on the back of the book. Give it a shot. And once you feel confident, move on to the next video. See you later.